Yes, audible.
Okay, 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 sir.
Good afternoon to all of you.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon,
afternoon,
sir.
sir.
Good afternoon, sir.
Good afternoon, sir.
गुड आफ्टरनून गुड आफ्टरनून
How are you, sir?
एकदम ठीक है आप लोग कैसे हैं
Fine, sir. सर अभी बस 2 मिनट और वेट कर लेते हैं, कुछ पार्टिसिपेंट ऐड हो रहे हैं, तो उसके बाद फिर सर स्टार्ट करते हैं।
ठीक है ठीक
Hello, Tanu ma'am.
Yes, sir.
Yes, ma'am. Start, please.
Okay, sir. Good afternoon, all the directors, HODs, faculty members, research scholar, and student from different colleges. In the afternoon session, our speaker is Dr. Lakshmi Kant Yadav, sir. We are thankful to you, sir, for giving your valuable time. Good afternoon, sir. I, Tanu Saxena, Assistant Professor of Engineering Department, welcome you on this STC on solar energy, a pathway to green energy. Dr. Lakshmi Kant Yadav, currently working as an Assistant Professor in Mechanical Engineering Department, NIT, Hamipur, Himachal Pradesh. He has 10-year experience. He has published 20 research paper in SCI Scopus Journal. He has supervised 15 MTech dissertation, one PhD pursuing. He has completed his PhD from NIT Kurukshetra. Overall, he is the shining star in the field of solar thermal energy. I request you, sir, kindly share your thoughts with us. Thank you so much, sir.
Thank you, ma'am, for your nice introduction. So it's my great pleasure to be a part of this STC, that is uh, green energy, solar energy, pathway of green energy. So I am very thankful to organizer of this STC, and especially thanks to Dr. Himanshu Agrawal for inviting me and providing this opportunity to deliver a expert lecture on this STC. So thank you very much, and good afternoon to all respected faculty members of your institute, and all students, all participants of this STC. So may I start the presentation?
Yes, sir. Sure.
Okay.
Thank you, sir.
Thank you, sir.
My screen is visible.
Yes, sir.
Am I audible properly?
Yes, sir.
Yes.
Sir, please do in slide mode.
Means?
स्लाइड मोड पे कन्वर्ट कर दिए सर पीपीटी.
अच्छा अच्छा, ओके ओके. पीपीटी विजिबल है अभी?
हाँ यस सर, अब
क्लियर है?
यस सर.
ओके. सो So my topic of the presentation or lecture is the desiccant dehumidification technology. So as the name indicates, dehumidification. So dehumidification means removal of water vapor or moisture from air. So this removal of moisture will be taken care by the desiccants. So that removal is either by the phenomena of adsorption or absorption. You are already aware about adsorption and absorption phenomena. If the desiccant material is liquid or liquid desiccant and moisture is removed by the liquid desiccant, then it is called absorption phenomena, absorption of moisture from air. And if solid desiccant is used or rotary wheel is used for the removal of moisture from the air, then it is called adsorption. So in this lecture, basically we will talk about the dehumidification, how we produce the dry air, how moisture can be removed from the air. So dehumidification technology. So the my lecture flow will be, first we will talk about the basics of dehumidification and its classifications. Okay, then we will briefly introduce the liquid desiccant dehumidification, liquid desiccant dehumidification, and air conditioning. The slide is visible now.
Yes, sir, visible.
Okay, then so we will briefly discuss about the liquid desiccant air conditioning system. Then I will detail discussion will be the about the solid desiccant. So solid desiccant dehumidification, dehumidification and air conditioning. Okay, so in solid desiccant dehumidification we will categorize in two parts. So one is the key area where the development of research has been already carried out in the field of solid desiccant dehumidification and air conditioning system. So the key research area where the research has already been carried out in the field of desiccant dehumidification and air conditioning in solid part, and the next part is the emerging research area where we can carry out our further research. So this will be helpful to the students, those who want to carry out their further study, those who want to study MTechs and PhD, and this will be also helpful for the BTech students for their project work and MTech student for their dissertation work. So we will divide the solid desiccant dehumidification air conditioning in two parts. That is the key research area where the research has been already carried out, and the second part that we will discuss, that is the emerging research area where we can focus, where we can do further research. And in this where here I also have done some research work. My PhD student, my BTech student have already done carried out some research. So I will show that slide also. Okay. So basically we will talk about the solid desiccant dehumidification technology. We will briefly discuss the liquid desiccant dehumidification air conditioning. So let us first start with the basics of dehumidification and its classification. Okay. So slide is visible now.
Yes, sir, visible.
Okay. So the basically that I have these slides I have taken from the internet, Google's, and some uh, expert lecture source also, and some research paper, and also my research paper. So and some books also like W.P. Jones and C.P. Arora. Okay, so these are my references. So dehumidification, already you know. So there are four principal methods whereby moist air can be dehumidified. So as you can see in the slide, cooling to a temperature below the dew point. So this is the first method of dehumidification, that we can say the conventional dehumidification. And second one is called the adsorption. So adsorption, that is when solid desiccant is used for the removal of moisture, then we call it adsorption. And absorption, when liquid desiccant is used for the removal of moisture, then it is called absorption. And compression followed by the cooling, this is also called the mechanical dehumidification. So here we compress the air above the dew point temperature, then we will cool this. Okay. So the cooling to a temperature below the dew point, that we already know, the in conventional system in air conditioning already we know we cool the air below the dew point temperature. So when we cool the air below the dew point temperature, the water vapor of air condenses and separated out. So because we are cooling the air below the dew point temperature, so that evaporated temperature is very low. And already we have studied in refrigeration air conditioning subject, when the evaporated temperature is low, the compressor work is high. So compressor work is high, it means the running cost is high, means electricity consumption is high. So in case of conventional system, when we cool the air below the dew point temperature, the energy consumption will be higher, because the electricity is also a high grade energy. So now we are focusing the sustainable energy development. So we want to utilize the low grade energy or heat energy to run the system. However, the conventional system uses the high grade energy, and also the running cost of the system will be also very high when the temperature will be very low. And the other disadvantage is that it uses the refrigerant, that is the HFC refrigerants, and that will be the harmful for the environment also. Okay, so is it clear? So the conventional
Yes, sir.
HVAC,
Clear.
the conventional evaporative cooler used for the space cooling consumes very little power but are insufficient when ambient high humidity. So let us talk about the evaporative cooling. So another method of cooling is evaporative cooling is also there. Then after we will talk about the, so what are the limitation of evaporative cooling is that we can cool the air up to wet bulb temperature. So the minimum temperature that we can achieve of air is that the wet bulb temperature of air. So that's why the temperature we achieve is higher in case of evaporative cooling. So we require higher mass flow because the load is the MCP delta T. Because in evaporative cooling the delta T is low because we can cool up to wet bulb temperature. So this dBT minus WBT, so this dBT minus WBT is less as compared to air conditioner vapor compression system. So this delta T is low, so we require higher mass flow rate to cool. So we can, you observe in summer the every home has a cooler, so the mass flow rate is very high. So we can say in case of vapor air conditioning system the air changes is 8 to 10 air changes per hour. However, in case of evaporative cooling, the same may be order of 20 air changes per hour because the delta T is less. So sensible cooling that we achieve in case of evaporative cooler is less. So we require higher mass flow rate. So that's why we feel some drop. The supply air quantity is very large, leading to condition of drop. So we not feel comfortable because the velocity is higher in case of evaporative cooler. So this is the oldest technology. The research is already going on in this evaporative cooling also. Okay, and the cooler is to be kept in good repair to obtain high efficiency. Otherwise, the dBT of air of the cooler will not be sufficient load to cool the space. So these are the some disadvantage of evaporative cooler. So we do not feel comfortable in the evaporative cooler. So basically we feel comfortable in conventional system, conventional cooling system. And conventional cooling, that air conditioner cool the air below the dew point temperature, and that is also called a access cooling, and again reheating is required. Okay, so cool air below its dew point temperature to separate out the moisture results into overcooling of conditioned air. So in case of conventional system, that is the access cooling. ठीक है, require excess energy to reheat this overcooled air before brought to the conditioned space, decreases its COP. So we feel comfortable in conventional HVAC system, that is heat ventilating air conditioning system, but the disadvantage is that it consumes a higher energy, or running cost is also high, and also the this is not environmental friendly. Okay, so this is about the first method of dehumidification, cooling to a temperature below the dew point. Okay, so now we will, so this is the psychometric representation of cooling and dehumidification process that I have taken from the CP Aurora. So the in the reality the process is like this blue line indicates the cooling and dehumidification, then again reheating is required. So this is the conventional HVAC psychometric representation. So this reheating is the wastage of energy. Okay, so again, so drawbacks with the conventional system for the cooling is that in conventional system, dehumidification of air is done by cooling it below the dew point temperature. So the moisture present in air is condensed and removed out. Dew point temperature is very less than the required cooling temperature of dew. Higher energy consumption, which is from primary source of energy such as coal, oil. Combustion of such fuel produce CO2 and other greenhouse gases that will cause many climatic disturbance. In hot and humid climate, the latent load is more, so the cost of producing optimum comfort condition is increased in convection. So in coastal area or in high humidity environment, when the contribution of latent load is more, the running cost also increases. Okay, so increasing demand of air conditioning needs alternative eco-friendly cooling system. So another alternative that we will search is the adsorption based dehumidification or absorption based dehumidification, that we will discuss, that is the adsorption and absorption. Okay, So this graph also represent the RH range associated with the different health issues. So you can see the maximum the bacteria or the growth of bacteria takes place in the either in the higher humidity range from 80 to 100%, similarly in low humidity range below 40%, and for fungi and mites you can see the this 30 to 60% is the desirable relative humidity for the this uh, fungi and mites, so that there will not be any fungi and mites and viruses and bacteria. So the desirable relative humidity is in between this 40 to 60%. Okay, so we have to make the space in the between these, so that this development of bacteria, viruses and fungi will be less. Okay, so this is also leads to the development of dehumidifier. Okay, for the safe product, to make the product safe. So let us discuss about the desiccants. So you already aware about the desiccant. So desiccants are drying agents. They are either solid or liquid substances that absorb water vapor due to the vapor pressure difference between the humid air and the porous structure of the desiccant. So desiccants absorb water particle present in air, so it is advantageous in handling latent heat. Once desiccant is saturated, it needs to regenerate for continuous use. It is easy to regenerate using low grade energy such as solar energy and waste heat. So for radiation, we provide heat so that water particle evaporate and desiccant is again ready for dehumidification. So once the desiccant is saturated, it require regeneration. So for regeneration, basically we use solar energy or waste heat. So basically the regeneration temperature is around from 60 degrees Celsius to 120 degrees Celsius. So depending upon the type of desiccant. So this temperature is low temperature. So that low temperature where we can easily achieve by the solar collectors. Okay. So the different solid desiccant materials that commercially used are the silica gel, zeolites, alumina, etc. And liquid desiccants are the calcium chloride, lithium bromide, lithium chloride, and triethylene glycol. Okay. Solid desiccant material are used in wheel having channels matrices in it. That wheel is called a desiccant wheel. So now the desiccant wheel is used, that is called rotary dehumidifier for the production of dry air. So basically that wheel is the rotary wheel. So where the desiccant material is deposited on the matrix of that wheel and we pass the air through the wheel. So it is a continuous phenomena. So adsorption and regeneration will takes place simultaneously. Clear? So this is the graph, that is the moisture removal capacity, adsorption capacity of different desiccant material. So we can observe that the silica gel having the higher adsorption capacity in the range of higher relative humidity from 60 to 100%. So in higher relative humidity, silica gel will perform effectively. However, we can observe the calcium oxide works effectively in the lower relative humidity range from 10% to 60%. So we will categorize this desiccant in next slide. So that is based on the um, its structure, that is the diameter of the capillary. So higher surface area and lower capillary volume. Similarly, higher capillary volume, lower surface area. So both are inversely proportional. If the desiccants having higher surface area, then its pore volume will be lower. Conversely, if the pore volume of the desiccant will be higher, then having the lower specific surface area. So on the basis of that, we will categorize. So the desiccant having higher pore volume works effectively in the higher humidity range, and the desiccant having higher specific area, surface area, but lower pore volume works in the lower relative humidity. So that we again discuss when we classify the types of silica gel based on its structure, that is the pore diameter. Clear? So you can see also the absorption capacity of silica gel is up to 40% maximum. Okay. So now we will discuss the absorption technology. So basically absorption is the bulk phenomena. So you can see in the figure, this is the absorption. So basically this is the liquid solution, either it will be a lithium chloride water solution or lithium bromide water solution, and this blue are the moisture particle or vapor particle that will be absorbed by the liquid desiccant, and the right side is called the desiccants like a silica gel particle. So there will be a porous, so in the surface there will be a diffusion of moisture in the surface, so there will be a single layer or multi-layer formation of moisture molecules on the surface of this silica gel particle or any desiccant material particle. So during the absorption and adsorption, so there will be heat will be released, and that heat is called the heat of absorption or heat of adsorption. So during the absorption or adsorption, heat will be released in the solution similarly in the surface, so that heat will raises the temperature of air as well as the desiccant surface. So this is the one of the features of the dehumidification. So during the dehumidification there will be a removal of moisture, but there will be a heating, because uh, when the vapor enters into the pores, this pores there will be a diffusion takes place, and the pore having the diameter of in the micrometer or in nanometer, and during this pore there will be a collision, and that diffusion is called the Knudsen diffusion. So during, so this act as a capillary, and during this capillary there will be a condensation, and that condensation is called the capillary condensation. So when there will be a condensation, heat is released. Okay, so that heat is called adsorption. So this capillary condensation is different from the other condensation. Basically condensation takes place when there will be a saturation pressure, but in case of capillary condensation, the condensation takes place before the saturation pressure. Okay, because of very less interaction, the interaction between the molecule is very less because of confined space, so there will be a capillary condensation, and due to that condensation heat will be released, and that heat will raise the temperature of desiccant material as well as air. Therefore we will get hot air, but the this is dry. Okay, so this is the one of the key feature of the solid desiccant. Or similarly in liquid desiccant solute, already we study about the vapor absorption system. In case vapor absorption system, and there is a absorber, in absorber there will be a heat release, so that heat will be compensated by the cooling water. So you already studied in refrigeration air conditioning system, there is a absorption, and that heat of absorption is compensated by a supplying a cooling water. Clear? So firstly we will talk about the liquid desiccant dehumidification system. This is just a brief introduction, then after we will start the solid desiccant dehumidification technologies. Okay, so you can see the figure. So there is a two chamber, one chamber is called the adsorption chamber, and other chamber is called the regeneration chamber. In the adsorption chamber, dehumidification of air takes place. So hot and humid air enters from the this below blower, and there will be a counterflow type of flow takes place between the spray liquid desiccant and this air. So there is a fill type of structure lying like in cooling tower, there is a fill to distribute the air and water evenly. So there will be more contact and more heat and mass transfer takes place. So here there will be a simultaneous heat and mass transfer takes place. So the mass transfer takes place from air to the liquid solution. So this mass transfer is basically takes place due to the vapor pressure difference between the air and the liquid. That liquid solution having a some vapor pressure, similarly the air having a some vapor pressure. So because the vapor pressure of air is high because of high humidity, so there is a vapor pressure difference, and moisture from the air is transferred to the liquid solution. Okay, so there will be a absorption. So during absorption there will be a heat release. So in some arrangement there is a some heat exchanger is provided here to compensate this heat of absorption. In this figure the heat exchanger is not here, but generally we provide heat exchanger is this field to neutralize this heat of absorption. Okay, and here the air will be the warm dry air, so that is further used either for the drying purpose or for air conditioning. We can use this air. Now the desiccants become the weak liquid desiccants, and or we can say strong in the water vapor. Now because this is just saturated in water vapor, so now it require regeneration because it cannot further absorb the moisture, so it require the regeneration. So this weak liquid desiccant is again sent to the heater, so where this desiccant is heated. Okay, now the vapor pressure increases, so the reverse phenomena takes place, that is called the desorption or regeneration. So because of heating the vapor pressure increases. Now the vapor pressure of this desiccant solution is higher than the humid air. Okay, so here the regeneration means removal of moisture, removal of moisture from the desiccant. So this is warm and humid air, so air will be humidified and this will be rejected to the surrounding. So once it is heated and air is supplied, now it is ready to again absorb the moisture. So this is now ready to use, so it is again supplied to this adsorption chamber by cooling. So we introduce cooling before supplying to this adsorption chamber, because of cooling will increase the absorption performance. Okay, so this is the basic working of liquid desiccant dehumidification system. So as you can see, this system is slightly complex like vapor absorption system. We have already studied in RAC. Vapor absorption system uses low grade energy, but it is complex. It occupy large spaces. Similarly, it occupy large spaces because it require the adsorption chamber, then regeneration chambers, then pump, some ducting work is also required, and also this desiccant is corrosive in nature, so the corrosion of duct may also takes place. So this is system, it can be driven by the solar energy or heater, but this system is complex in nature. However, in case of solid desiccant, we will discuss in further. The solid desiccant is a simple wheel, so no requirement of adsorption chamber or regeneration chamber or duct to flow the liquid. Okay, here only one wheel that is rotated and continuous adsorption and desorption takes place. Okay, so the advantage is there and disadvantage is there also, because okay, so here the regeneration temperature requirement is low as compared to solid desiccant. Here regeneration temperature may be even 50 degrees Celsius to 70 degrees Celsius. The low regeneration temperature can require. However, in case of solid desiccant, we will discuss the regeneration temperature for some calcium chloride or desiccant will be higher, that is around 100 degrees Celsius or 120 degrees Celsius, even high. Okay, so regeneration temperature requirement is higher in case of solid desiccant. However, in case of liquid desiccant, the regeneration temperature requirement is low. Similarly, the heat of absorption is also low. However, in case of solid desiccant, heat of absorption is higher. Okay, so this is one of the advantage, or we can say disadvantage. Okay, so this is the vapor pressure diagram. So during the adsorption part, so because the ambient vapor pressure is constant, so this is during the adsorption. So during the absorption, the vapor pressure of ambient is higher than the vapor pressure of this liquid solution. However, in case of regeneration, the vapor pressure of liquid solution is higher than, because of heating. As we heat the solution, the vapor pressure increases, and that vapor pressure is higher than the ambient vapor pressure. So there will be a regeneration. Clear? Next, this is also represent the desiccant surface vapor pressure diagram. So you can see A to B. A to B is the dehumidification. So A to B. So this is basically dehumidification chamber. So there will be increase in a desiccant concentration because there will be absorption. So desiccant concentration increases from A to B, and B to C is again the, where is B to C? B to C is the heater is required, so there is a constant concentration, but the vapor pressure increases. Then C to D is again there will be increase in desiccant concentration because the removal of moisture, so there will be increase in. And D to A, where is D to A? D to A is the cooler, so cooling. So this is the vapor pressure diagram versus concentration diagram of liquid desiccant. Okay, so this graph represent the uh, basically the conventional air conditioning and desiccant air conditioning. You can see this is the conventional vapor compression system. So in conventional vapor system, the air is supplied to the cooling coil, so there will be a condensation. So the condition of air is almost saturated, so again reheating is required. So this is the excess wastage of energy. So this red line shows A, B, C, D. This red line indicates the conventional cooling representation in psychometric chart. However, this AED represent, this green color represent the liquid desiccant air conditioning. So A to E represent the chemical dehumidification of air. So A to E is the chemical. So during the A to A, so basically A to E is the process in the dehumidification process. So after that, so this is the dry air. So the dry air is again we can use the either indirect evaporative cooler or direct or sensible cooling to meet the room sensible heat factor line or supply condition. So the right side will consume less energy as compared to left side. So many people already carried out research on this comparison of simple vapor compression system and liquid desiccant air conditioning system, and they found that the COP of liquid desiccant air conditioning system is overall COP is higher than the simple conventional air conditioning system. Okay, so this is all about the comparison and psychometric chart representation. So liquid desiccant solutions. So these are the some commonly used liquid desiccant, that is called lithium chloride, lithium bromide, calcium chloride, and some composite desiccant having the 50% calcium chloride, 15% lithium chloride. Okay, so these are the commonly used liquid desiccant. So already research has been carried out, and research is going on this field in liquid desiccant also, like in composite desiccant or this desiccant. Okay, for the, but in case of if you want to develop a setup of liquid desiccant air conditioning system, then you have to require two chamber, adsorption chamber, regeneration chamber, pumps, heat exchanger, but you can develop this system. So okay, however the desiccant wheel is simple compact system. There is one wheel where dehumidification and adsorption continuous takes place. Clear? And another disadvantage of liquid desiccant is that there is a carryover loss. So when there will be a adsorption, some particle of lithium chloride or lithium bromide also enters into the room. So that is the carryover of the liquid desiccant. So during the adsorption, some liquid fraction of liquid desiccant may also enters into the room. Similarly, during the regeneration, some liquid fraction of lithium chloride or lithium bromide also come out to the atmosphere, so they may also pollute the atmosphere. So this is the one of the disadvantages, the carryover loss. So it is called a carryover loss. Clear? So this is the carryover of liquid desiccant. So this is the disadvantage of liquid desiccant system. So this can be used either by the drift eliminator at the air outlet duct and low mass flow rate of air, with the use of random. So we can, so many research is going on to remove this carryover loss. Okay, so what are the merits of liquid desiccant cooling system? Avoid excessive energy use and space from overcooling. Energy consumption is less than solid desiccant cooling system. So this is the outcome of different research that is carried out in the field of liquid desiccant. Low pressure drop as compared to solid. Avoid heating in the air while drawing it. Okay, so heat of adsorption is less as compared to solid desiccant. Control humidity precisely with rapid response. Easy to install and maintain. So you can develop this setup in your college or here. Okay, manufacture from simple and low cost equipment. So basically the simple, we can manufacture the chamber duct with the help of GIC blower duct system. So liquid desiccants have the ability to filter different bacteria. So these are the advantage. So it can filter the bacteria, some viruses also. The dehumidification and regeneration of liquid desiccant simultaneously are eliminated because weak liquid desiccant can be stored until regeneration heat is not available. So this is the one of the great feature of the liquid desiccant. Another is the long life. What are the demerits of liquid desiccant cooling system? So demerits is the liquid desiccant, lithium chloride, lithium bromide, and all salt are corrosive to metal. So this is one of the concern. So during the duct designing of the duct, carryover along with supply air stream causes significant harms to the health of the occupant. So this is the already told. To handle a large volume of liquid desiccant, large pumps are required which draws a large amount of fire. So handling liquid desiccant is also a difficult. Okay. So this is just all about the liquid desiccant, just a brief introduction of liquid desiccant air conditioning. Now we'll move to the solid desiccant, that is called active desiccant. So as the name indicates, active desiccant wheel means it requires energy to drive. So we require here heater, a solar air heater is required. That's why its name is active desiccant wheel. In further slide, we also discuss about the passive desiccant wheel. So the passive wheel is the wheel that does not require hot air to operate. It requires hot air to continuous operate. So that's why it is called the active desiccant wheel. The passive desiccant wheel is the one which does not require hot air for the regeneration of to operate continuously. Okay, so one motor is used to drive the desiccant wheel. Okay, so this is the cross section of the desiccant wheel. This is divided into two parts. One is called the reactivation section, this is small section, and this larger section is called the adsorption section or process section, where dehumidification of takes place. So here the process air or atmospheric air enters into the desiccant wheel, and there will be a dehumidification. So this dry air is warm air. So there will be heating because of chemical dehumidification, because of heat of adsorption. And this is the reactivation. So we will heat the atmospheric air. Okay, and due to this will remove the moisture from the desiccant. In the adsorption section, moisture is transfer takes place from the air to desiccant. So in adsorption, moisture transfer takes place from air to desiccant. In case of reactivation section, the moisture transfer takes place from desiccants to air. So again, desiccant is ready for the ready to adsorb the moisture. And the one small motor around 6 to 10 watt power motor is used to drive the wheel. So advantage is that it can be operated by a low regeneration temperature, 60 to 80 degrees Celsius, and that temperature we can easily achieve by the solar air heater or waste heat, okay, of the industry. So this cross section is the cross section of the desiccant. So you can see the cross section is like a sinusoidal channel. So first we make a sinusoidal channel of fibers. So we make the sinusoidal channel of fiber. So in that fiber, we deposited the silica gel desiccant or molecular sieve desiccant on that fiber. So that fiber that initially is called the matrix material or substrate. Okay, and on that substrate we coat the desiccant material. Okay, so this is the shape of the channel. Sinusoidal channel is used because the sinusoidal channel offer higher surface area. Because of higher surface area, it provides higher convective mass transfer, but the disadvantage is that it having the higher pressure drop also because of sinusoidal shape. Okay, The desiccant wheel is a rotary air-to-air heat and mass exchanger. So there will be a simultaneous heat and mass transfer takes place. Okay, because heat of adsorption is released, capillary condensation takes place inside the pores of the desiccant, and due to this, heat transfer also takes place. So this is the air to air heat and mass exchanger. And in regeneration section there will be a hot air, so this heat of hot air is transferred to the desiccant, and when this desiccant rotates into the process section, this heat is comes to adsorption section. So basically this wheel is simultaneous heat and mass exchanger wheel, we can say. Okay. Generally, it is divided into two sections, namely adsorption section or process section and regeneration section. So, rotary motor with power of 6 to 10 watt is used to drive the desiccant wheel at different rotational speed. So, one of the key feature of the desiccant wheel is the rotational speed, and rotational speed is very low, around 15 to 20 rph. So, this is the optimum rotational speed of the, this is revolution per hour. 1 घंटे में in 1 hour to in 20 revolution. Okay, so this is the front view. You can see the adsorption section and regeneration section, and these are the driving system, and these are the sinusoidal flow channel that is indicated in the zoom. So principle of chemical dehumidification that we already studied in CP Aurora. This figure is from CP Aurora. So you can see the ideal case, there is a constant WBT, constant enthalpy process, but in reality the adsorption dehumidification deviate from this ideal line. So this is the 1 to 2. So sensible heating, because of heat of adsorption, most of the desiccant material like silica gel, activated alumina, this heat of adsorption is very high. Heat of adsorption, I have already told that heat which is released during the condensation of vapor into the pores of the desiccant. So that heat is very high in case of silica gel and activated alumina, and due to this, gain in sensible heat is higher than the latent heat. So during condensation, latent heat is rejected from the water vapor, which raises the desiccant and air temperature. This additional heat is called the heat of adsorption. This heat with desiccants such as silica gel and activated alumina is very large. Thus, the sensible heat gain of air exceeds the loss of latent heat, and process line 1-2 lies above the constant wet bulb temperature line. So, due to this, its performance also decreases. So, in case of ideal, this is the performance. However, in case of reality, this is the, so temperature increases and dehumidification performance also decreases because of heat of adsorption. If there is any arrangement of cooling in the desiccant channel, then that may improve the performance. So it is very difficult to arrange a cooling arrangement in desiccant wheel that is in the solid desiccant. However, in case of liquid desiccant, we can easily introduce a heat exchanger. As we have already studied in liquid system, we can easily introduce a heat exchanger here to neutralize the heat of adsorption here to cool supply water. So heat of absorption can be easily neutralized in case of liquid desiccant system. However, in case of solid desiccant system, it is very difficult to neutralize the heat of adsorption in solid desiccant wheel. Okay. So I will talk about the one research paper that introduce a heat exchanger in desiccant wheel also. So that researcher is the Australian researcher. So that I will show in the further slide. Clear? So that the physical structures of the silica gel. So this physical structure is very important for the adsorption point of view. So basically they govern the isotherm curve. That isotherm is the graph of adsorption capacity versus relative humidity, or we can say eta. So you can see the silica gel, there are three type of silica gel B, silica gel third A, and silica gel RD. So we observe that the silica gel RD have the higher specific area, okay, but lower pore diameter. Okay. So silica gel RD will perform effectively at lower RH. So in lower RH environment, silica gel RD, that is called the regular density silica gel, will perform effectively. However, if we see the silica gel B, the surface area of specific surface area of silica gel is less, but the average pore diameter is very high. So due to this, the adsorption capacity at higher RH will be higher, and capillary condensation is also more, and heat of adsorption and for silica gel will be also be higher because of this capillary condensation in the pores. So this is the very important property of the silica gel, that is called the total surface area and pore volume. So that graph we have already studied. Okay. Now we will talk about the application of dehumidifier. So the different application of dehumidifier are the sugar storage, cooking, drying, potato chips, chocolates, where the relative humidity requirement is 35%, 20%, 20%, 30%. It is very difficult to obtain this relative humidity condition with the help of conventional system. So in that situation, the desiccant will plays a very important role uh, to obtain this type of dehumidity. And this is the one of the important application of desiccant wheel is the dry environment is required in the production room of lithium battery. So this is the very important application of desiccant wheel, and due to this it is commercially successful. Desiccant wheel is not commercially successful in air conditioning, but it is commercially successful in the this type of industry. Dry environment is required in the production room of lithium battery. So this is very important. Okay, so the requirement of lithium battery application is that, so you already aware about the application of lithium battery. So non-maintenance of desired RH lithium cell manufacturing and battery assembly may lead to severe consequences. So if relative humidity is greater than 1%, so that will damage the production of the lithium. Due to this reason, there is a demand for large scale production of lithium ion battery, but it is not easy to meet due to the stringent moisture control requirement for the production to occur without severe consequences, which is a major deterrent to the growth of this industry. So in lithium ion battery production room, we require the relative humidity of less than 1%, even 0.1%, and this type of strict relative humidity can only be controlled by the only the use of desiccant wheel. Okay, not with the help of conventional system or liquid desiccant system. So this type of relative humidity requirement we can easily achieve with the help of desiccant wheel. That's why this desiccant wheel is commercially success. Effect of uncontrolled humidity for the lithium ion battery, we can say the lithium batteries are affected by the uncontrolled temperature and humidity. If the lithium battery is exposed to moisture during the production, it may lead to impairing quality. Thus it leads to reduced product life, reduced performance, raised safety concern, including chances of explosion. So pure lithium metal is extremely sensitive to even teeny amount of moisture in the air. Hence, slightest top exposure to moisture lead to reduced performance and reduced product life of lithium ion battery. So due to this reason, the desiccant wheel is commercially successful in lithium ion battery industry. So what are the recommendation during the production of lithium battery? So moisture level in the lithium battery processing area should have less than minus 35 degrees Celsius, and this is the dew point, not the dry bulb temperature. 35 degrees Celsius dew point temperature, and room dBT is 25 degrees Celsius. And if we calculate a 25 degrees Celsius dBT and minus 35 degrees Celsius dPT, so your relative humidity will be around 0.7%. So this much relative humidity environment is required for the production room of lithium ion battery, and this much relative humidity we can easily achieve by the desiccant wheel system. Clear? So we will quickly discuss the application because we have only 15 minutes to finish the lecture. So So why desiccant system is required? Because we can control the humidity separately. In case of conventional system, the we control the sensible cooling and latent cooling simultaneously. But if we use the desiccant wheel, we can control the humidity separately and we can control the temperature separately. So separate control is quite accurate. So we can control both temperature and humidity separately with the use of desiccant air conditioning system. So these are the typical solid desiccant air conditioning system where we use desiccant wheel, enthalpy wheel, direct indirect evaporative cooler for the air conditioning. So many researchers indicate that the solid desiccant air conditioning system has higher overall COP, and it also saves the environment by the refrigerants, because if we use indirect evaporative cooling and direct evaporative cooling for cooling, so there will not be any use of refrigerant, so it saves the environment also. Okay, so the parameters which affect the performance of desiccant wheel, so these are the key area where the research has already carried out in the field of desiccant dehumidification system. So different design parameters of the desiccant wheel are the channel length, channel height, channel width, channel thickness. Similarly, the operating parameter of the desiccant wheel is rotational speed, regeneration temperature, flow rate, and desiccant property of material. These are the porosity, structure of the desiccant, specific heat, thermal conductivity. So these are the emerging area where I have done my work. Also my PMTech student and PhD students are working in the different design and configuration of desiccant wheel. So these are the 3, 4, 5 sector of desiccant wheel, internal heat exchanger desiccant wheel. Okay. So you can see this is the channel of the desiccant. So this is the height of the channel and this is the pitch of the channel. So these are the design parameter and these are the thickness of the channel, so where air flows, and this is the substrate. This is called substrate. So this is represented here, this thickness. So there is a substrate material that is made of fiber. In that fiber we coat the desiccant layer of this. So when air flow takes place here, so here the moisture transfer takes place from air to desiccant due to vapor pressure difference. Okay, so here we can see this base material is called substrate or fiber, made of fiber, and this is the thickness coating of the desiccant in this side. So these are the design parameters. Some performance indices that are the moisture removal performance, DCOP, dehumidification coefficient of performance, we calculate to indicate the performance of the desiccant wheel. Similarly, the sensible energy ratio. So these are the performance of the desiccant wheel at different rotational speed, different regeneration temperature. So optimum rotational speed is around 10 to 15 rps. So similarly, the regeneration angle is around 90 degrees. So generally the two sector desiccant wheel that is available of 270 degree of process section and 90 degree of regeneration section. So because of this reason, because the performance is higher. Similarly, the wheel length generally we found around 0.2 meters. So generally wheel length of 0.1 meter and 0.2 meter of wheel length of desiccant wheel is available in the market. Okay, so these are the some performance characteristic of the desiccant wheel. So now we introduce some emerging area of desiccant wheel where we can do the research. So that is called the introduction of purge section. So
सर
generally,
प्लीज समराइज कर दिए सर,
ठीक है
क्योंकि नेक्स्ट लेक्चर भी है सर 2:30.
okay, thank you. So these are the per section. So we can install the per section, third per section. Generally the desiccant wheel is divided into two sections, so we can install the per section, though that per section will reduce the power consumption also. ठीक है, so the reduction of regeneration energy up to 30%, up to 70% post cooling. So per we can all do research in per section. So we can divide the desiccant wheel in many sector and introduce the per section. So this is the scope of research. So effect of purge angle, and similarly we can also divide the desiccant wheel more sectors, 4 sectors. So these are the new configuration of wheel. So this type of configuration, so generally we are doing research in the new configuration of desiccant wheel for better performance. So this is the internal heat exchanger desiccant wheel. So here's internal heat exchanger is provided to neutralize the heat of adsorption. So this is the Goldworthy White. So this is the recent work around in 2012. He introduced the internally cooled desiccant wheel to neutralize the heat of absorption. So this is the recent advancement. Okay. So another wheel, that is the passive desiccant wheel. So passive desiccant wheel does not require for the hot air for the regeneration. So this is the one of the emerging areas. So we can do also research in the passive desiccant wheel. In active wheel we require hot air shades. However, in passive wheel we don't require hot air shades. We pre-cool the air before the desiccant wheel. So this is the emerging area. Similarly, this is the two-stage humidification. So we have done the work. My MTech student has published a research work where two-stage humidification is performed in a single wheel. So this is a generally two-stage humidification is performed by the two wheel, but he introduced a new design type of desiccant wheel where two-stage humidification we can achieve by dividing four sector and counterflow direction by pre-cooling. So we can achieve two-stage humidification in one wheel. So this is the recent work. So also we can install the desiccant wheel in cooling tower to reduce the water consumption. So if we introduce the cooling a desiccant wheel before the cooling tower, we can save some water. So this is the also our BTech student have carry out some experimental work. ठीक है. So this is all about so we can do research in different configuration of desiccant wheel. So I can say we summarize: the earth, water and the air are not a gift to us from our parents but a loan from our children. So save energy and conserve energy. So thank you very much to listening me. Thanks. If you have
Thank you so much, sir. On behalf of Army CET, I extend a very hearty vote of thanks to Dr. Lakshmi Kant Yadav. Sir spread time from his busiest schedule to grace this occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage our student and our future work. So, once again, thank you so much, sir.
Hello,
hello.
sir. I have some questions. Can I ask?
Yes.
So, sir, I wanted to know the method how to optimize the rotation speed of the desiccant wheel.
Basically,
You can briefly describe.
we have also developed a mathematical model. Okay, so where we can do the simulation, where we can.
Sir, I wanted to know the experimental method because I am working on desiccant wheel, and is there any experiment way so that we can find a desiccant wheel speed experimentally?
So when you perform the experiment at varying air speed, then you observe that at only 15 to 20 rph only the desiccant will have the higher adsorption capacity. In higher rotational speed, in beyond 20 rph or in 10 rph, the either the speed is too high or too low, and that is not optimum for the dehumidification.
So
Either too speed is too fast, speed is too fast for the means very less time is available for the adsorption, and for if speed is very less, then time available is very large, and that is redundant in nature. So
sir, actually the parameters which is I have calculated is amount of dehumidification.
okay.
So is it sufficient for us to decide whether the rotational speed is this much or
Yeah,
something else I have to
basically the performance criteria of desiccant wheel is two parameter. One is the humidity ratio, exit humidity ratio, and exit temperature. Okay, so
Okay.
as the exit temperature we cannot control moisture. If moisture removal is higher, exit temperature will be higher. So if we optimize, if we on the basis of moisture removal, then temperature obviously will be higher. So one parameter we have to sacrifice, either temperature. If you want to optimize the desiccant wheel on the basis of exit temperature, then you can some other configuration of desiccant wheel or some other method to control temperature we can use. Okay.
Yes, sir. And one more question is there. So, sir, can you?
अनुराग प्लीज वेट, सेकंड लेक्चर का टाइम हो रहा है, आप सर की मेल आईडी पे प्लीज शेयर कर दीजिए.
Okay, sir. Sir, can you write your mail ID in the chat box? Sir?
हाँ हाँ,
Okay.
श्योर, ओके. थैंक यू सो मच टू ऑल ऑफ यू. थैंक यू सर.
Thank you so
Thank
थैंक यू
you.
डॉक्टर लक्ष्मी सर.
So you can see my email ID from NIT Hamirpur website na. So if you write
Yes, sir.
Lakshmi
Yes,
Bang,
sir. Sure.
okay, so you can my contact number is also there, so you can see from.
Thank you, sir.
थैंक यू सर.
Thank you, sir. Thank you so much, sir.
Thank you. So may I leave, Dr. Himanshu?
या श्योर सर.
Thank you.
Thank you, sir. Thank you.
मुझे भेजिए लिंक सर. लिंक भेजिए, अभी आ रही हूँ, बस ये कनेक्ट कर, ठीक है.
पेट कहाँ से खुलेगा? पेट. पढ़ा था सीरियसली. सर्टिफिकेट मिलेगा इन लोगों को ऐसे? सर्टिफिकेट रुक जाएगा इनका ऐसे? सर्टिफिकेट ऐसे फटवाएगा ऐसे करो. हाँ. डॉक्टर साहब, इसको डिस्कनेक्ट करवाइए.
हेलो.